Cats are known to respond to certain plants, such as catnip and silver vine. When cats encounter these plants, they rub their faces and bodies against them and roll on the ground. In Europe and North America, catnip is a famous cat-attracting plant. In East Asia, it's silver vine. Both plants have been recognized as cat-attracting plants for centuries. But what happens when cats encounter catnip and silver vine at the same time and are free to choose? The new study therefore focused on free choice conditions, where cats could freely approach, ignore, or walk away from the stimuli. The research group first carried out outdoor experiments in Japan. They placed fresh branches and leaves of silver vine and catnip in a garden that free-roaming cats could freely enter and leave. Now, let's take a look at the behavior of a free-roaming cat. It reacted only to silver vine and completely ignored the catnip. Across 10 nights of testing, 5 cats consistently rubbed and rolled on silver vine, but never on catnip. Even when only the plant extracts were presented, the same pattern emerged. A cat rubbed only against the side of the brick that had been treated with silver vine extract. Even after sniffing the catnip side, it went back to the silver vine side and resumed rubbing. 3 of the 5 cats showed a stronger tendency to respond to silver vine-derived stimuli, and none responded only to catnip-derived stimuli. To test whether this pattern was limited to a small group of local free-roaming cats, the researchers next studied captive purebred cats originating from Europe, the United States, and the Middle East. They were in a large indoor environment where they could move freely, and there were dozens of filter papers treated with catnip and silver vine extracts. Here, the captive cat responded exclusively to the silver vine extract, immediately beginning rubbing and rolling behavior. Among 22 cats, about 70% of the cats, 15 out of 22, responded only to the silver vine extract. 3 responded only to the catnip extract. 1 responded to both, and 3 sniffed the papers but did not rub or roll. Overall, cats were significantly more likely to respond to silver vine extract than to catnip extract. At this point, the researchers encountered a paradox. Almost all of the known bioactive compounds in catnip were napetolactones. In contrast, silver vine contained the major active compound napetolactol, together with several minor active compounds known as mattatobilactones. Previous laboratory studies showed that napetolactone and napetolactol have comparable bioactivity in cats, whereas mattatobilactones are less potent. Surprisingly, catnip contained about 170 times more of the known key active compound than silver vine. This means that catnip clearly contains sufficient amounts of biologically active compounds capable of triggering the characteristic response.
Catnip also contained 2 additional isomers of napetolactone, isomers 2 and 3, compounds made of the same atoms but arranged in slightly different shapes.
Notably, isomer 2 was almost as abundant as the major known active compound isomer 1, whereas isomer 3 was present at less than 1/10 of that level. The team tested whether these isomers could also trigger the typical rubbing and rolling response in cats. Laboratory bioassays revealed that these isomers triggered rubbing and rolling behavior when cats are kept close to the stimulus.
This created a paradox. Catnip contained about 340 times more bioactive compounds than silver vine. Yet freely moving cats often ignored it.
Under laboratory conditions, cats are kept close to the stimulus, and catnip reliably triggers rubbing behavior. But under free choice conditions, cats can simply ignore it. The researchers proposed that intact catnip plants may release odors too strongly or too continuously under natural conditions. In other animal communication systems, Excessively strong chemical cues can sometimes reduce attraction rather than enhance it. The researchers therefore speculate that the strong odor plume from fresh catnip plants may reduce the likelihood that cats engage in rubbing and rolling behavior. This idea may also help explain why dried catnip products are widely effective for domestic cats. Drying likely reduces the amount of airborne chemicals released, potentially shifting the stimulus into a more effective behavioral range. In conclusion, when cats can choose freely, silver vine beats catnip. Detecting biologically active chemicals is not the same as choosing to act on them. What matters is whether animals voluntarily engage with the stimulus. So, what happened when catnip and silver vine were planted side by side overnight? By the next morning, free-roaming cats had heavily damaged the silver vine. The catnip was left almost untouched.